Let's practice solving quadratic equations by taking square roots together. Well, I know there's some different strategies for solving quadratic equations like factoring or using the quadratic formula or even completing the square. For this particular video, we're going to focus on solving these quadratic equations by taking square roots. Just to start off, I'm going to just copy down the equation. So we have 5x squared plus 10 is equal to 310. And when we solve these equations by taking square roots, what we really want to do is isolate whatever is being squared. So let's first get rid of this 10 on both sides of the equation. So using the subtraction property of equality, we can take away 10 from both sides. If we do that, we're going to be left with 5x squared on the left side, and then 300 minus 10 is going to be 300. And then we're going to go ahead and divide by this 5 so we can get a coefficient of 1. So 5 divided by 5 is going to equal 1x squared, or just x squared. That's a division property of equality. And on the right side, 300 divided by 5 is going to equal 60. Okay, so we've isolated what is being squared here, which is x squared, and what's going to be the inverse of squaring is going to be square rooting, or taking the square root. So the square root of x squared is just going to be x, and on the right side we're going to have plus or minus the square root of 60, right? So there's a positive root and a negative root. And at this point, what we want to do is take a look at this radical and make sure it is fully simplified. If it is not, we need to make sure we take care of that. So I think 60 has something inside of it. So if we take 60 and we break it down, we can find some perfect square factors. So I'm going to go ahead and just go all the way down to having prime factors here. So let's see, 2 and 30. For 30, we have 2 and 15. For 15, we can say we have 3 and 5. Okay, so all of our prime values here are going to be 2, 2, 3, and 5. And so these are all the prime factors. Now, if you go ahead and multiply any two of these together that match, like 2 and 2, that equals 4, then that means that's going to be a perfect square. And then it looks like this 3 and 5 don't have any partners, so 3 and 5, we're going to make that 15. Okay, so 4 times 5 is 60. Hopefully you agree that is true. And so the square root of 60 is the same thing as the square root of 15 times the square root of 4. Right, so we broke it up into a perfect square, which is 4, and then 3 and 5 didn't have partners, so you just multiply those together to get back to 15. The square root of 4 is just going to be 2, and the square root of 15 can't be simplified. It has no perfect squares inside of it, so 2 root 15 is the same thing as the square root of 60. Okay, so what we can do for our final answer here is say x is equal to plus or minus 2 times the square root of 15. That would be the solutions here. Now, in case you had to separate these and write two separate answers, you could also say that x is equal to positive 2 root 15. You can also say that x is equal to negative 2 times the square root of 15. So while these are the exact versions, if you just wanted an approximation, you can go ahead and round it maybe to the nearest hundredths place. This is about 7.75 roughly, and this is going to be roughly negative 7.75, right? So it's a little bit cleaner to write them as radicals because they're irrational values, but if you were looking at what values of these would approximately be on a coordinate plane, it would be about positive 7 3/4 and negative 7 3/4. All right, for number 2, we have 81x squared plus 5, and this is equal to 21. And so again, just like in number 1, what we want to do is isolate whatever's being squared, so that x squared. First, we're going to start by using the subtraction property of equality and subtract 5 from both sides. If we do that, we're going to be left with 81x squared is equal to 16. Now, to get the coefficient for x squared to be 1, we can go ahead and use the division property of equality, divide both sides by 81. 81 divided by 81 is 1, so we have 1x squared. Not going to write that 1, so x squared is equal to 16 over 81, right? So that's just going to be a proper fraction right now. And so if we want to get x completely alone, the inverse of squaring is going to be taking the square root. So we're going to take the square root of both sides here. And so that's just going to leave x on the left side. And we're going to have plus or minus the square root of this 16 over 81. Now on the side here, we want to think about this square root of this fraction of 16 over 81. So let's go ahead and think about that on the side here. Well, if we have the square root of 16 over 81, keep in mind that one of our properties of square roots means that if we have a fraction, we can go ahead and separate this into two different radicals. So square root of 16 on top and square root of 81 on bottom. The square root of 16 is actually a perfect square, so that's going to be 4, and then the square root of 81 is actually 9. So the square root of 16 over 81 is actually just equal to 4/9. So we can say that x is going to be equal to plus or minus 4/9. And those would be the two solutions to this equation. Now, if you wanted to write these separately, you absolutely can say x would equal positive 4/9. And you could also say that x is equal to negative 4/9, and these would be the exact values. And if you're looking for the approximation as a decimal, this would be positive 0.44 roughly, rounded to the nearest hundredths place, and this would be negative 0.44. Here's number 3. For number 3, we have 3/4 multiplied by the quantity of this x plus 2. That whole thing's going to be squared, and that's equal to 96. Okay, so if we know we're going to have to be getting this whole thing isolated here that is being squared, this x plus 2 squared, we need to be getting rid of this 3/4. So if I were you, I would actually go ahead and change this 96 that's on the right side and just rewrite it as a fraction from the beginning and write 96 over 1, just because you're going to see we can use the multiplicative inverse to move the 3/4 away. So we can go ahead and multiply the left side by 4 over 3, which is the multiplicative inverse. It's the reciprocal of 3/4. Then we can go ahead and do that to both sides using the multiplication property of equality. Notice here if we do that this 4 and 4 and 3 and 3 are all going to cross cancel on the left side. And on the right side, this 3 and 96 will cross cancel. 3 goes into 96 32 times. So that's what those two numbers are going to become. Now, if we go ahead and write this next step here on the left side, we're getting rid of that 3/4, so we just have the quantity of x plus 2 squared. And on the right side, we really have 32 multiplied by 4, and 32 times 4 is going to be 128. Now at this point, we can see that whatever is being squared is isolated, so it's time to take the square root of both sides of this equation. The square root of x plus 2 squared is just going to leave us with x plus 2 on the left side, and on the right side we have plus or minus the square root of 128. Now, this 128, I believe, has some perfect squares hidden inside of it, so we need to try to get those out. So let's take a look at this 128 on the side. So 128, we can break that into maybe 2 times 64, right? And we can break that down if you would like to even more. But we notice here that 64 is a perfect square. So if we have the square root of 2, that would be one of our factors here. And the square root of 64, that would equal the square root of 128. Right? So it's helpful to kind of know that 64 is a perfect square here. You could keep doing what we did in example 1, where we made the entire tree, but I just noticed that 64 was a perfect square, so we can stop there. The square root of 64 is 8, and the square root of 2 is irrational, so we're just going to keep it the same. So 8 times the square root of 2, or 8 root 2, is the same thing as the square root of 128. Okay, so we can go ahead here and write that x plus 2 on the left side is equal to plus or minus 8 times the square root of 2, or 8 root 2. Now, to completely isolate x, we can take away 2 from both sides of the equation using the subtraction property of equality. And so we're going to get x plus 0, or x equals, and then we're just going to write the rational part of negative 2 plus or minus 8 times the square root of 2, which is the irrational part. So this right here represents both solutions for this quadratic equation. If you wanted to separate these into two different ones, we could write x is equal to negative 2 plus 8 root 2. We could also write x is equal to negative 2 minus 8 root 2, and those would be the two solutions. And if you were more comfortable with just kind of seeing what these were approximately as decimals, this negative 2 plus 8 root 2, rounded to the nearest hundredths place, is about 9.31. I'm going to go ahead and write it like that. And then if we were to take the negative 2 and take away 8 root 2, that would be about negative 13.31, rounded to the nearest hundredths place as well. All right, for number 4, we have a fraction going on here. So we have negative 1/2 x squared, and then we're adding 1, and that's equal to this negative 39. Okay, so first things first, let's get this x squared alone. So let's go ahead and take away 1 from both sides of the equation. If we do that, then we're going to be left with negative 1/2 x to the second power. And then on the right side, negative 39 take away 1 is going to be negative 40. Okay, so actually we want to go ahead and get rid of this negative 1/2. So on the right side, let's actually write this as negative 40 over 1, just because I know I'm going to want to try to use the multiplicative inverse again. So let's go ahead and multiply the left side by negative 2 over 1. Let's do that on the left side, and on the right side, let's multiply by negative 2 over 1 as well. Okay, so if we do that, notice that this negative and negative become a positive, because a negative times a negative is a positive. These 2's are going to cross cancel to become 1's, And on the right side, these negatives are going to cancel out to make a positive as well. So on the left side, we're just having x squared. And on the right side, we really have this 40 times 2, which is going to equal 80, right? So we have x squared equals 80. At this point, the x squared is completely isolated, so we can go ahead and take the square root of both sides. After you take the square root of a square, you're just left with what's inside the radical, which is x. And then we have plus or minus a square root of 80. Okay, so at this point, let's take a look at the square root of 80. I do believe there is a perfect square hidden inside of it. So let's see if we can extract that and get that out. So 80 can break up into, I don't know, we could start off with maybe 8 times 10. And then 8 can break into 2 times 4. This 4 can break into 2 times 2. And this 10 can break into 2 times 5. Okay, so let's see. We have some prime factors here. We have 2, 2, 2, 2, and 5. And remember, every 2 that we compare together of the same number gets us a perfect square. So 2 and 2 make 4. That is a perfect square. Another 2 and 2 together make 4. That's another perfect square. And this 5 doesn't have a partner, but that's okay. But this 4 times 5 does equal 80, right? So the square root of 80 is the same thing as the square root of 5 times the square root of 4 times the square root of 4. The square root of 4 is 2. The square root of 4 is 2. So 2 times 2 equals 4. So we can say that 4 root 5 is equal to the square root of 80. So our simplified radical here is going to be x is equal to plus or minus, and we said 4 root 5. Now again, that's the same thing as the square root of 80, and those would be our two solutions. Now if you wanted to separate the two solutions, we could say x is equal to a positive 4 root 5. We could also say that x is equal to a negative 4 root 5. And just in case you wanted to see what this was approximately as a decimal, this would be about 8.94 rounded to nearest hundredths place, and the second one would be negative 8.94. Here's number 5. For number 5, we have this equation where we have negative 2 multiplied by the quantity of x plus 7, that whole thing squared, is equal to 150. To get started, we need to isolate what's being squared, so we have to go ahead and divide both sides by negative 2. Use the division property of equality. If we go ahead and do so, dividing both sides by negative 2, you can see on the left that these negatives will cancel out with each other and the 2's will become a 1. So on the left side, we really are just going to be left with x plus 7 squared, that whole quantity squared. And on the right side, 150 divided by 2 is 75, but because it's a positive divided by negative, it's negative 75. Now that we have what's being squared on the left side isolated, we can go ahead and take the square root. Let's do that on the right side as well. So on the left side, we're just going to have x plus 7. And on the right side, we're going to have plus or minus the square root of this negative 75. Now let's go ahead and deal with this square root of negative 75. Because it's negative, we're going to have to deal with some imaginary numbers. So let's keep that in mind, right? So first things first, let's separate this square root of negative 75 into the square root of negative 1 times the square root of 75. Let's just do that first, because we know the square root of this negative 1 is just going to equal I. So then we just have to deal with the 75. Okay, so the 75 we can break down and say maybe something like 3 times 25. And then you can actually stop there because 25 is a perfect square. So we have the square root of 3 times the square root of 25. That's equal to the square root of 75, right? Because 3 times 25 is 75, so the square roots of them multiplied together is the square root of 75. So the square root of 25 is just 5, so this really becomes 5 root 3 equals the square root of 75, and that would be the simplified radical. So just gonna go ahead and write 5 root 3 here. Okay, so if we multiply I and 5 root 3, that's gonna be 5I root 3, so going back to the equation, we can write x plus 7 is equal to plus or minus 5I root 3. Now to get x completely isolated, let's go ahead and take away 7 from both sides of the equation. If we go ahead and do so, we're going to get x is equal to negative 7. And we're going to write plus or minus 5I root 3. Okay, so this represents both solutions for this quadratic equation. We just have imaginary solutions for this one. If you wanted to write them separately, we could say that x would equal negative 7, that's the real part, plus the complex or imaginary part, which is 5I root 3. And our other solution would be x is equal to negative 7 minus 5I root 3. So those would be our two solutions separated. All right, for number 6, we have this problem where we have this negative 1/2 multiplied by this x plus 5 squared, the quantity of x plus 5 squared, and that's equal to 27. So if we see that we have a fraction on the left side and we might want to be using the multiplicative inverse, I'm just going to go ahead and write 27 as 27 over 1 from the start. To get rid of that negative 1/2 on the left side, I want to go ahead and multiply by negative 2 over 1. And so I'm going to do that on the right side as well, multiplied by negative 2 over 1. Okay, so on the left side, we can see here that these negatives will cancel out. These 2's will cross cancel and become 1's. So really on the left side of the equation, we're left with this quantity of x plus 5 squared. That's on the left side. And on the right side, nothing can really cross cancel. We just have to multiply 27 by 2. That's going to be 54, but it's going to be negative 54 since it's a positive 27 and a negative 2. And then now that the x plus 5 squared is isolated, we can go ahead and take the square root of both sides of the equation, right? So on the left side, we'll just have this x plus 5. And on the right side, we're going to have plus or minus the square root of negative 54. Okay, so this square root of negative 54, this radical, we got to take a look at it and see if we can simplify it a bit. So let's go ahead and take out the negative 1. So it's the square root of negative 1 multiplied by the square root of 54. Now the square root of negative 1 is just I, and then let's take a look at the 54 and see if we can find some perfect squares inside of it. Okay, so I'm thinking 9 times 6 just because I know 9's a perfect square, and 6 won't break down into 2 matching numbers. It's just 2 times 3, so at this point we can say that we know that the square root of 9 times the square root of 6 does equal the square root of 54, right? The square root of 9 is 3, so we know 3 root 6 is equal to the square root of 54. So we know this is I times 3 root 6. Okay, so combining those together, I times 3 root 6, that would just be 3I root 6. So going back to our equation, we can say x plus 5 is equal to plus or minus 3I root 6. Finally, getting x completely alone, let's take away 5 from both sides of the equation. If we go ahead and do so here, then on the left side we just have x. On the right side we have negative 5 plus or minus this 3I root 6. This would be the 2 solutions for this quadratic equation, and they're both complex or imaginary. Okay, so if we want to separate these, feel free to do so. We can say x is equal to negative 5 plus 3I root 6. Or we can say that x is equal to negative 5 minus 3I root 6. So those are going to be the 2 complex numbers or 2 complex solutions. Here's number 7. For number 7, we have the opposite, or a negative 1 multiplied by the quantity of x minus 8 squared is equal to 98. Okay, so we're going to get rid of that negative 1 that's in front, so we can do that by dividing both sides by negative 1. If we do that, then these negative 1's and negative 1 on the left side will cancel out with each other, and we're just going to have the quantity of x minus 8 squared is equal to negative 98 on the right side. Then we can go ahead and take the square root of the left side and take the square root of the right side. If we do that, then the squared and square root will cancel out, so we're just left with x minus 8 is equal to plus or minus the square root of negative 98. So now that we have this radical, let's go ahead and take a look at it and see if we can simplify it a little bit here. It is a negative radical, so we know we're dealing with imaginary numbers. And let's take away the negative 1, or rather separate it. So take the negative 1 over here and leave the 98 by itself. The square root of negative 1 is I. And let's figure out what this 98 is really made of. Let's see if we can find some perfect squares inside. So I'm thinking maybe 49 and 2, right? 49 times 2 is 98. Just divided by 2 since it was an even number. And we notice that 49 hopefully is a perfect square, right? So the square root of 49 times the square root of 2 is equal to the square root of 98, right? Feel free to break down that 49 more, but it's just going to be a 7 and 7. You're going to combine those back again. So the square root of 49 is 7. So we really found out that 7 root 2 is the same thing as the square root of 98. All right, so this 98, square root of 98 separates into, or simplifies to 7 root 2. So if we go ahead and multiply these together, we're going to get 7I root 2. So going back to your equation, we can write x minus 8 is equal to plus or minus 7I root 2. And then to get x completely alone, let's just go ahead and use the addition property equality and add 8 to both sides. If we go ahead and do that, then on the left side, we're left with x is equal to, then we're going to have a positive 8 plus or minus 7I root 2. So we have two complex solutions again. Okay, so these are our two solutions. If we want to go ahead and write them separately, I can show that as well. So we can write x is equal to 8 plus 7i root 2. Right, and then we can also write x is equal to 8 minus 7i root 2. Finally, number 8, we have one final equation. We can say that we have this negative 3/5 out in front being multiplied by the quantity of x minus 4 squared, and that's equal to 48, but I know we have a fraction in front, and I'm going to use the multiplicative inverse, so I'm just going to write 48 over 1 to start here. Now, to get rid of the negative 3/5, let's multiply by the reciprocal of negative 5/3 on the left side, and on the right side, let's do the same thing, multiply by negative 5/3. If we go ahead and do that, then these negatives will cancel out on the left side. The 5s will cross cancel, and then these 3s will cross cancel. So everything's going to cross cancel on the left side, and we're just going to have the quantity of this x minus 4 squared on the left side. And on the right side, notice that this 3 and 48 can cross cancel. 3 goes into 48 16 times. So then multiply this 16 by 5, that's going to be 80, and it's going to be negative 80 just because we had a negative times a positive. Now to get rid of this squared, let's go ahead and use the inverse, which is taking the square root. So we go ahead and say that on the left side, we're going to have the quantity of x minus 4, that's all we have left. On the right side, we have plus or minus the square root of negative 80. Now that we've taken the square root and we have this radical, let's see if we can simplify this radical a little bit. Again, just like the last few, we have a negative value, so it's going to be complex or imaginary. And so let's separate the negative 1 out, and then let's take the square root of 80 and see if we can find some perfect squares inside. Okay, so 80 can break down into, let's see, 16 and 5, right? And 16 is a perfect square. So we can say the square root of 16 times the square root of 5 is equal to the square root of 80. The square root of 16 is 4, so 4 root 5, or 4 times the square root of 5, is equal to the square root of 80. So that's what the square root of 80 simplifies to. And so if we have I times 4 root 5, that's just going to be 4i root 5. So going back to our equation, we can say x minus 4 is equal to plus or minus 4i root 5. And finally, let's go ahead and add 4 to both sides of this equation to isolate x completely. So if we go ahead and do that, then we're going to have x is equal to 4 plus or minus 4i root 5. This right here would be our final solution. We have two of them, so these would be the two complex solutions for this equation. And if we wanted to separate them, we can say that x is equal to 4 plus 4i root 5. And our other solution would be x is equal to 4 minus 4i root 5. So there you have 8 different practice problems on solving some quadratic equations by taking square roots. If you found it helpful, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.